Welcome to the Commerce Tomorrow podcast, your one stop to learn about the technology that's powering the future of commerce. Here are your hosts, Dirk and Kelly.
Welcome to an episode of the Commerce Tomorrow podcast. I'm joined with my co-host, Dirk Horig, and today we have the pleasure of interviewing Amir Konigsberg. He is CEO of Twiggle. Welcome, Amir.
Thank you very much. It's great to be here.
We like to start all of our episodes by asking our guests if they could tell us a little bit about themselves. How did you get to Twiggle? I'm sure it was a long journey.
Yeah, it's a great question. It was a long journey. I had been wanting to do, so Twiggle's a company that does search technologies in a very new kind of way, and I'll speak more about that later on. But I'd been fascinated with the area of search for about 20 years. And for a very, very long time, I'd been wanting to do something in the search space. But it took a long time to find the right thing to do, because in a market which is dominated by very, one or two very large search companies, it isn't clear, or it took a long time to find the right business on which to build a search company. So the journey started many years ago, and what's fascinating to me about search technologies is that to do them well, or to build a good search company, you not only have to understand and figure out how to leverage the most advanced techniques in search, in natural language processing, and in artificial intelligence and machine learning, you also have to understand people. So it's not only about technology, it's also about psychology. And these two disciplines of computer science and psychology have been disciplines which I've been fascinated with all my life. Search is an intersection between them, because search is really what people are searching for, how they think about things that they want, how they express their intents, and the different nuanced ways in which they do so. And building a good search technology is something that has to touch on both these areas. So getting to the point at which we founded Twiggle took a while, and it involved, obviously I didn't know at the start that I wanted to build such a company, but I guess my background at companies such as Google, such as My Supermarket, which is an e-commerce company, such as working on natural language processing in autonomous vehicles, as well as a PhD in rationality and decision sciences, led me to this area.
So I saw in your bio that you were at General Motors before, and you did some work around human and machine interfaces for autonomous cars.
Yeah.
Could you talk a little bit about that? And we're kind of curious what major lessons you've learned from that experience.
Sure. So first of all, one major lesson I learned from that experience is that the automotive industry is a very different industry to the industry that I was working in beforehand, which was basically the internet industry, which is Google. Mm-hmm. I worked at Google. I was fortunate enough to be one of the founding members of Google's operations in the emerging markets, and in a business and in a area which is able to move very, very fast, and development cycles are very quick, as opposed to the automotive industry, where I found myself in an industry where the cycles of producing a car can actually be 5-6 years, which is a very, very different, because of complexities, because it's real, tangible things that have to be on the road. It takes a long time. So what fascinated me about the idea at General Motors, and I joined roughly after the bailout, and GM decided to focus on building assets which would help take the whole organization forward. They decided to set up an advanced technical center of excellence in Israel, which is generally a place where tech talent is very good, and lots of innovation happens in the specific areas which GM wanted to advance. And they structured the organization in such a way where it would be under GM's venture capital arm, as well as its advanced technology center. And today that center has about 300 or 400 people, but back then we were very, very few. And the core areas which we were working on were smart sensing, which was basically vision systems. It was human-machine interaction, HMI, which is a more traditional, it's a field which actually is used less. It's named. People use that term less in the internet space, but it actually comprises various things such as speech recognition systems, search systems, infotainment systems, virtual and augmented reality systems, everything that really happens between the interaction of the driver or the passenger with the vehicle in which they're in. We also had a wireless connectivity group as well. So my work there basically focused on working on the interaction between a driver and passengers and the vehicles, which were then in the process of transitioning between regular vehicles as we know them today to semi-autonomous and autonomous. Semi-autonomous vehicles started off with things like Super Cruise, which was basically the ability to define a distance between two vehicles rather than define a set speed. And that allowed the car to take some of the control that the driver used to have. So in that sense, because in a certain position, the vehicle was now driving for, while it could, so to speak, see, then the driver was free to do something for a few seconds. And then human-machine interaction really had to understand what kind of systems, what kind of alert systems, what kind of entertainment systems, and what kind of information consumption systems and services you can build, which on the one hand are very useful and efficient, and take into account the type of real estate you have to work with within a vehicle, and also to take into account the cognitive state in which the driver is in, which is something also which is very difficult to figure out, and also the external conditions on the road. And that requires you to think very differently about how you deliver information, how you sense what the driver's state is. We did all kinds of things back then. We looked at everything from galvanic skin response to pupil dilation to try and understand whether the driver was focused or whether he or she was zoning out on the road. We were using sound to try and alert the driver to their environment. So these are the kind of things I was working on at General Motors. More specifically in the search space, working on interfaces which are really able to deliver information to the driver based on how they express themselves. Now, this requires lots of understanding about a driver's contextual situation and lots of understanding about language. I'll give you an example. So, let's say you're in a car and you're not going to, as a driver, you don't write, you don't type, you speak normally. Now today, or in most cars, speaking or speech is very constrained to, you can search for someone in your contact list, or you can search for a particular point of interest. In that sense, it's a very well-defined and constrained space. But if you were to actually have a more general system that had to be contextually sensitive and based on speech, and based on what the driver was actually saying, and you said something like, find me Chinese. while you're driving on the 101. And the system would have to figure out, first of all, that by phrasing yourself in that way, you're probably looking for a restaurant in your area, as opposed to Chinese people or a Chinese object or China the country. And to do that, you have to have lots of information about what people say when they drive, what they mean when they say those things. And then you have to also figure out how best to retrieve that information, which being the correct information, the ones that the driver actually intended. And second of all, and then how to deliver that information. Should you deliver that visually? If so, how? So you can't deliver it as a link. Do you deliver it as kind of a large object? You know, I've actually got a patent around this area about information delivery in vehicles. And then if you're going to speak the information out, how do you rephrase what you found in a way which is actually not too cumbersome for the driver to consume or absorb or take away too much of their attention? So very interesting and complex problems, far from being solved. Many things to do in that space still, but they're very interesting because, you know, as the vehicles do get more autonomous in an actual vehicle, your experience and the time you spend in a car becomes time which you can actually do different things than we've done today. You can work in the car, you can shop in the car, you can speak to people in the car. It's monetizable, so there are different revenue streams.
Yeah. No, absolutely. So I couldn't agree more.
But very interesting time.
I think in 10 years or 15 years, the cars will look completely different than they look today, because it's just not that four people need to look into the same direction and one has a steering wheel. And there's a lot of change going on. So we are working also with many automotive companies currently on how that is changing. But, well, as you had deep insights and also an amazing and interesting time there, I've two more personal questions, as I'm also a car guy. And with a couple of friends, I also have some bets going on, actually. What is the year when things are changing? So from both a technical perspective and a market rate or adoption perspective, what do you think? When will we actually have autonomous driving as a standard, or at least the majority on the main roads? So when you go from Palo Alto to San Francisco, when you drive from Munich to Berlin, or these kind of ways. So when do you think, is it two more generations of cars? Or what is your feeling from both that angles?
Yeah, so it's a great question. I'm going to do the annoying thing and actually outline together with you what I think the issues are. And then at the end, I'll give you kind of a prediction. Okay, but let's outline what the issues are. First of all, I think we can agree that from a technical standpoint, there are autonomous vehicles today.
Yeah.
I've been in several. I've been at GM's autonomous vehicles. I've been in the Mobileye autonomous vehicles. Mobileye, the company acquired by Intel. These vehicles work today. Are they perfect? Probably not, but they're very good. And then, I mean, the bigger issue here is that there are several bigger issues. I mean, how can these, you know, it's like if you have, and this will relate back to search actually in a very interesting way and surprising way, but when you have, let's say, an autonomous fleet, let's say you've got a highway full of autonomous vehicles, it's like having a fully structured search. Mm-hmm. Nothing, you know, with perfect information, perfect retrieval, you have perfect results. And then you have to kind of optimize all that based on a person, but that's a different issue. So if all the vehicles are optimized and they can all chat to each other and talk and communicate to each other in a perfect way based on algorithms, there's no real problem. Assuming that they don't fail and their systems are good, then it should be fine. The problem is that you've got to have many vehicles on the road which aren't autonomous, meaning you've got human error involved and you've got drivers. And then, you know, you've got the generation until all those drivers get rid of their cars and they start taking autonomous vehicles. And then the barrier there, I think the threshold, and you hinted to this in your question, I think that the threshold there it's not necessarily going to be about just about the technical capabilities or technical achievements or progress of autonomous or semi-autonomous vehicles. It's going to be about how these all fit into an infrastructure, how the infrastructure for the future of driving is actually set up in such a way that we can think of the car owner in 10 years' time, whether that car owner will, take the autonomous, get rid of their car and buy an autonomous one. It has to be more than the fact that the autonomous vehicles will work. It has to be a full system and lots of regulation involved, and it has to be cities adapting their infrastructures and a full, large urbanization process which supports this. So that's one thing. The second thing is the large issue, and I remember this from, I haven't been deep in this area for the last 4 years, but 4 or 5 years ago, a big issue was the large car companies were asking themselves, well, even if we do have fully autonomous capabilities, how do we cover ourselves in scenarios where things go wrong? And they will go wrong. Even if they go wrong 1 in a million, that one, whose responsibility will it be? It will ultimately, if I say this vehicle is in control right now, then and something bad happens, then I'm liable for what happens, and I'm responsible for it. How do we deal with that situation? And I think part of the terminology around or semi-autonomous and autonomous functions is actually being framed in such a way which it puts the responsibility on the driver. If you notice the nuances of the way the large companies kind of describe all these kind of new automated functions, the driver of the car, which is actually utilizing these functions, in most cases is actually the one who's still in control, at least from a legal standpoint. So there's that issue. So I don't know, and this is where, after all that mumbo jumbo, I'll tell you kind of what my prediction is. I think at least 35 years. Okay. And 35 years, I don't expect this to be kind of a Blade Runner type world. I do think, though, that we're going to see 30 years. We should be able to be in a position, and I'll explain why 35 years. 35 years, we should be in a position where we can actually see, highways with fleets on them, highways with all kinds of autonomous vehicles, driverless cars, driverless public transport, and this will give us enough time to put in place the infrastructure for all of that to happen, and for the large car companies to adapt, and for the municipalities and the countries to adapt. It's a very, very complex issue, and to be honest, I don't really see any large corporation or entity, governmental or commercial, taking a lead on really spanning out what the greater future dynamics of building such an infrastructure will look like. Do you understand what I mean by that? I mean, I haven't seen someone showing a macro picture of all of that.
No, absolutely, right. So we are currently reinventing a complete new game of transportation, and as it's a complete new game, the rules need to be written, and a lot of people, company, countries, organizations are involved in that. So it will take time. I think, I wouldn't say, well, some maybe also I hope, because I like innovation in that field, but I also think that there is a big motivator, and the motivation here is economy, I think. So the companies and countries that move faster than others, I think, are in a competitive advantage. So probably this is, but yeah, it's nothing that will happen overnight. So and probably in maybe a few trucks and other services, we will see stuff coming sooner than later, right? So if they are on the interstate, just following one by one, probably powered by electric engines, then this might happen faster. But of course, having a car in heavy traffic in multi-million people city, just watching a movie and sitting faced backwards, this definitely will take a little bit longer probably until especially legal and insurance and other things are sorted out. So.
Yeah, I agree.
Okay, so I could go on with the automotive topic, I think, for hours, and probably we will have a separate episode on that, and then we have to invite you again, and then we'll talk about this topic more. But so let's get closer to Twiggle. So before we get into that, maybe one question, because there's always a lot of buzz going around when companies are talking about AI, and it feels like every company now needs to put AI somewhere on their website and on their marketing papers, and they are investing there. And then there's a huge mix up also with machine learning, or sometimes it's used in the same sentence even. Can you quickly describe what is AI and how it's differentiating from machine learning for the audience, so that it's getting probably a little more clear, and even with your academic background, giving some information on that?
Yeah. So I mean, first of all, let's I'll be blunt. Outside of academia, AI is a buzzword. Mm-hmm. It means whatever you want it to mean. Full stop. Realistically, the world is redefining itself today around data, around algorithms, and around learning capabilities from that data, and around various means of making sense of data. That's the big shift, I think, that's happened recently, that all companies have, or most companies have understood that there are ways of moving things forward in respective areas of different industries, be it health, be it automotive, be it commerce, by using data and by using very available and cheap computing power, and using algorithms, by the way, which have been around for a long time, to either make processes more efficient, or to automate them, or to glean insights by discovering patterns, or by increasing our predictive capabilities. In that sense, that's I think, to in a nutshell, that's the way I describe what's going on today. I think, AI can be 10 years ago, 12 years ago, IBM's Deep Blue was considered, IBM's match with Deep Blue was considered AI, and the Jeopardy was considered AI. Today, no one's speaking of that as AI, because there are a new set of techniques that are being used today, over the past few years, I think primarily since DeepMind and autonomous vehicles. And I think, they're the talk of the day today, deep networks, deep learning, other approaches. But all of these things belong to a large group of techniques and methodologies which broadly are considered artificial intelligence. I think that within another area is the area of really machine learning, of which things like deep learning are a subset. And what we're seeing today is a lot of use by many companies of data, which is readily available, in many cases, by the way, it has to be created and curated and cleaned and enriched before it can be usable. But once there is data and that data is publicly available, then learning systems can really discover different patterns within data, gain insights from that data that a human couldn't, simply because either of the depth or the dimensionality or the size or scale of the data, or because sorry, I lost track of thought. But I think the main thing here is really, the second thing was all that data can really provide us with better predictive capabilities than we had beforehand. So meaning because we learn more from data using various machine learning approaches, when we can predict what is more likely to happen in a very different way. In that sense, we're improving our ability to say what's likely to happen, and then we can build different systems and different interfaces on top of that, which are less likely to be wrong. In that sense, let's take a vehicle camera, for instance, a sensor, which is now able to absorb lots of information in real time, having a system which is able to learn from video footage what the vehicles are likely to see, and is able to then absorb and dissect and cluster and analyze and glean insights from that, from what it sees, and then it's able to devise kind of patterns to which a set of rules are matched, and then you have a system which is able to respond to its environment very similar to how a human would respond to that environment. And the key difference here is that prediction capabilities are increasing, interfaces then become more useful and closer to human-like capabilities. And then we have a very cool and efficient and advanced system. And it's important to say that we haven't seen this in many areas. I think we've seen it in some areas. We're slowly seeing these advances in more areas. The first areas were areas such as automotive, primarily because of vision systems. Commerce is another area where we've seen this. Health is another area where we've seen this. Healthcare, the scans now being automatically detected, or problems and being automatically detected by algorithms and so on and so forth. But gradually we're seeing more and more industries being impacted by these advances and by being data-centric and also leveraging learning technologies and AI approaches.
And why? So you've had a pretty diverse background, right? And you seem to be very well versed in AI and human interaction, right? That's a pretty broad space. So why, as a team, did you decide to go into search? And how did you get Twiggle off the ground?
So, we went with search because I think search is one of the most important areas, and one of the important areas and most dominant areas in our lives as not only as consumers but as users of digital technologies. When we talk about search, many people have in their mind a desktop computer with a Google homepage in front of them, but essentially a search system is what not only underlies that, but it's underlying any database from which you want to retrieve information, any speech system to which you want to have discourse with. So within speech systems, there are two typically. Any smart speaker you see today, be it Alexa, Google Home, or anything else, or any voice recognition system, once it recognizes the audio input, it then translates that input into a textual string, which is then actually based on search, and then information is retrieved just like a normal search engine. The same is true of conversational systems. You probably remember this 3 years ago, everyone was talking about bots. That was a way overhyped area, which I think we can all agree nothing really came out of it so far. It's kind of the bubble has been, I actually called this at one point the bot bubble, and the bubble has been deflated. But underlying real conversational technologies has to be a conversational system, which is essentially a system which recognizes input as audio or text, it doesn't matter, and then is able to respond with the appropriate piece of information, and then take that response of that information, then converse with it. This is a very, very interesting problem, and as I said at the beginning, it relates to human psychology and advances in fields such as AI, and it's a fascinating area, and it's also a very important one, not only in terms of the general capabilities of generic search engines like Google, Yahoo, Bing, Baidu, but in specific industries, and we chose commerce, it's actually the point at which a customer shakes the hand of the merchant, the seller, right? When you go into a physical store and you want to buy something, you walk in with either with an intention or you're just browsing, and then you find what you want to buy, and then you get to the till, and then you pay. On the digital world, the point at which that happens is, at least in 50% of the cases, that's through search. Now, that area, for about 20 years since search, internet, e-commerce began, basically more or less with Amazon, that area hasn't really advanced too much. So Google has advanced tremendously, but specifically to commerce, which is a completely different use case for search, what had actually happened until Twiggle came around was that the same approach which was applied generically for all kinds of enterprises and all kinds of different industries was also applied to commerce. And if you'll remember, Google actually back in the day had a few shots at commerce. They had now it slipped my mind. They had about 3 different variations of trying to create an e-commerce business, and they weren't successful. The current product that they have is actually very, very successful, but previous to that, they had a few different approaches to it, which were basically using the generic Google search system and just putting it on top of products, which doesn't really work because it's a different use case. What's very important in this is that the traditional approach that had been used by e-commerce companies, retailers, brands, and e-tailers had been keyword matching, meaning you go to a search engine and you type in 1 or 2 or 3 words that describe what you're looking for, such as white sports shoes or white Nike shoes. And then the engine takes those words and it looks for those words in the database of all the products that it has. Now, the problem that happened, which we all experienced as consumers, was that it also picked up products which were not what we were looking for, but had the words white Nike shoes. It picked up white products which were Nike, and it picked up Nike shoes that weren't white, and it picked up also shoes that weren't Nike and weren't white, simply because it was looking for the same keywords. Now, in that sense, it worked very similar to how the Control F function works on a Microsoft Office product. But obviously, over the years, there have been different advances in this area, such as using behavioral data, such as learning technologies, which are able to kind of look at what people are actually clicking on after they search for a particular query, and then learning from that for the next time. But there were no tremendous advances. And the problem was that when we founded Twiggle, even before we founded Twiggle, we saw that the market itself was in a very difficult situation. We saw that Amazon basically was the market leader and was growing stronger and stronger and stronger. Today, that's very clear to everyone, but that wasn't clear 5 years ago. I mean, not everyone saw this. And for sure, not everyone outside the e-commerce industry saw this. We did. And we understood that Amazon has several assets beyond the fact that it's got it's been around, it's the oldest e-commerce player. It also has lots and lots of data, which it's kept to itself. such as query data dating back 25 years of all the ways people search for products, as well as interactions that it has had for many, many years about how people respond to different offers, different pricing, and different results when they're given those results. And we also saw that Amazon as a company had created massive advantages for itself by creating core infrastructures. It had built an organization called A9 back in the year 2000, initially to compete with Google, but then it turned A9 into an organization which basically focused on creating search technologies for Amazon. Then it also built its what then became to be its cloud-based systems, because it had special needs for itself, the scale. That turned into AWS. It then built its own manufacturing systems. It acquired Kiva systems. And these things, these basically gave Amazon a very, very strong position in the market. Then we looked at the rest of the market, and we saw that the rest of the market didn't have these capabilities. Even the large e-commerce companies and the world's biggest retailers didn't have the advantages that Amazon had. They didn't have Amazon's data, and they didn't have Amazon's technologies, and Amazon wasn't sharing these with anyone. And the rest of the companies essentially weren't tech companies, whereas Amazon is one big tech company. Amazon this year, I believe they spent $18 billion on R&D, which makes them the biggest R&D spender in the world, bigger than IBM, bigger than Intel, bigger than Google. But that's huge, and that would have been unbelievable 10 years ago, but that's the way it is today. Moreover, Amazon's retail business and its ability to invest in these core infrastructures powering the future of commerce is actually largely financed by AWS, which is not something that other retailers have the ability to do. They've got shareholders who have to be tolerant to their spending on R&D. So we found a very large niche here, which really needed advancement. We were convinced, and still are convinced, that the future of commerce is going to be based on more structured and more advanced technologies that relate to search and discovery. And we saw that, it didn't make sense for all these large retailers to transitioning to being technology companies overnight. It just didn't work that way, and it would be very, very difficult to do. And we envisioned a market where large retailers actually begin to consume microservices, because essentially Amazon was the only company Amazon and perhaps Alibaba in China, the only company who really had the whole tech stack of the whole chain, from search to delivery and return. They own the whole chain. Rest of the companies needed to kind of consume microservices, and we decided to be the company that really advances as much as possible and be the leader in the space of the search area. We didn't want to touch any other area but the search and discovery area, and to specifically focused on what we believed would be the most advanced technology in that space, which was really leveraging natural language processing and data structuring capabilities in this area.
Let's talk a little bit about how Twiggle actually works. Probably not in too much detail, but as far as I understood, and where everybody can check out the website, so twiggle.com, and then you can see the search results and a couple of examples on your own, right? So you can try it out. But how does it work down below? So what is actually, so to explain to everybody, the USP here, because it often also depends on the data, right? So if the product, what can you do, for example, as Twiggle, if the product data quality is so-so? Well, you have probably name, color, and a short description and material. So if we look on fashion, but we could apply it also to other products. So how does it technically work? You are on top of the existing search engine and the catalog, and what do you do then? And
okay. So there's several questions here, so I won't go into too much detail, but let's pick up on where we said before the problems in traditional e-commerce search were. The problems are that you put in a search query, and you get a set of results based on the words that you've typed. Those results actually look at the things like the product page, which has titles, it has a product spec, it has a description, it has reviews, it has an image, and they look for keywords in all of those. What Twiggle does, which is very different, it uses an approach which is also called structured search. Other companies had used this in the past. Companies like Wolfram Alpha, Google have used a similar version in the past. What this does is it does two things. On the first thing it does is we built natural language processing systems, but not generic ones that are uniquely tailored to e-commerce. What that means is they're uniquely focused on understanding the language in which people express themselves when they search. And that varies by cases when you search for shoes, to when you search for tables, to when you search for cars. You look for different things. And the grammatical structure is different. The semantics are different as well. So on the one hand, we build those systems. On the other hand, we have a very, very, very deep ontology. And I'll explain what an ontology is. An ontology is basically a representation of the world. And in this case, because we are vertically focused, we have a representation of the e-commerce world. And what that means is that we have a representation of every single product type in the e-commerce world. So I'll give you an example now. Let's take a product type. Let's take table as a product type. To have an ontology that relates to table means to have some kind of abstraction of what it means to be a table. It means that you have a certain shape. It means that you have a certain utility or purpose. You can be a coffee table, a dining table, an outside table, or a snooker table, or you can be many other things. And then it means that it has other qualities such as how many legs does a table have? What are those legs made of? What material is the table itself made of? Does it have a topping on it? Does it have glass on it? Is it meant for families or kids? How many people can sit around it? How resistant is it to heat? These are all examples of things that are involved in understanding tables. And this is what you'd expect from an expert who knows about tables to be able to answer questions about tables. Our ontology for tables has to represent all these things in abstraction. Think about it as a graph, which has the concept table at the beginning, and then various nodes which connect to the central node, which is a table. And those nodes are all features or attributes or qualities or values which relate to tables. Now, for each of those nodes, there are also other nodes that relate to it. So if you have one node which relates to table, which is size, the nodes that would relate to table size would be about, it could be the circumference of the table, its diameter, or its height, or its width. And then for, let's say, something like width, you'd have other nodes that relate to the width in centimeters, in inches, in meters, and so on and so forth, and on and on and on. Now, that's just one product. Once you have a representation of all products, billions of products in the e-commerce world, then you're able to encounter any product from basically any retailer or any data source, and you're able to map it automatically to our ontology. And in that process, the product data itself is understood by our systems. So for instance, you gave an example before of a product which you didn't have much information about. If our systems can detect, given the information that does exist for that product, what it is, they can then enrich the information about that product using our ontology and then deliver that back. Once that process happens, it means that you now have a product with rich and structured information. And the problem that's really solved here is that you can do this for all kinds of products. no matter what their source of information is. So let's say you've got, to give another example, let's say you've got two cameras. You've got a Canon camera and you've got a Sony camera. Each of those has a different manufacturer and they have different types of data. Once these are mapped into our ontology, they are then normalized in terms of all the data, all the attributes, all the values are normalized into a common language. We call this Twiggle query language. And they're given a uniform representation. That means they will be picked up by the search, no matter how nuanced or different that search will be. And that's a very, very powerful technique. And they're always picked up by our natural language systems. The way the system itself integrates, the workflow itself is that we're the first company to deliver this capability through an API. There are other companies that deliver search as a hosted service through an API. What we deliver here is search enhancement, meaning we wanted to be able to support companies without those companies needing to rip out or replace their existing search infrastructure. And what we needed to do to be able to do that is to provide a layer of enhancement to their existing search stack by giving them really the capability of natural language processing, of data enrichment, product to data enrichment in one. So essentially, Twiggle's input is a search query and product catalog. Its output is a set of search results for each query, which can then be used both for relevance, for improved relevance and improved ranking. And these results, all the process which I just described, is given back in under 10 milliseconds. So this is a fully automated, very, very powerful, very robust process.
No, that's fascinating, and I think that's why, in part, we find you so interesting as a company, is because you're working on top of legacy, and you're enabling those legacy search platforms to do things that they otherwise wouldn't be able to do. So, if we look at Elastic, for example, right, the makers of Elasticsearch, they filed to go public. There's a lot of money out there these days. How do you stop the platforms on which you sit from adding these features themselves, right? Because clearly they don't want to be left behind, and artificial intelligence and machine learning is hot. What's to stop Elasticsearch from adding a lot of these features over the course of the next couple of years? And how do you stay ahead?
Yeah, it's always a good question. I mean, I think that I can tell you what's happening today, and I think this is one great way of actually describing some of the limitations of machine learning. So, and then I'll answer the question. I mean, think about machine learning as a way to learn from data. What, in the case of search, you see many search queries of a certain type, and you see results for that search. And then after you see that many times, you infer that if they clicked on a particular result, given a particular query, then that was probably the right result. Then you show it higher up or more often. That's pretty much the limit, really, of what you can do in that scenario with machine learning. And the primary focus there is to improve data. What you can do with a structured search solution, like I described, is actually break down search into a dialogue, which is not something you can do using the machine learning approach, or it's very difficult to do it in that way. What I mean by a dialogue, and you can actually try this on twiggle.com on the product demo there, you don't have to type in all your search at once. So if you go to that demo, and for instance, and I encourage the listeners to do this as well, go to that demo and type in a product type. Type in polo shirt. And then you should see a set of shirts, of polo shirts as a result. And then add to that some more specific information, such as the color you want, let's say yellow. And then you don't have to take off polo shirt, you just add the word yellow to it, and now you have yellow polo shirts. And then you can be specific about something else you want, such as you want yellow polo shirts for men, and then you add that word. And then you add the price that you want, let's say under $60. Essentially, what you have here is a multi-stage process, which is very similar to a conversation. So that progressive search process, which we just showed, is a kind of combination between browsing or filtering and searching in one. And it's very similar to the type of human dialogue that you have if you were to walk into the Gap and say, I'd like a polo shirt. And then the shop assistant would say to you, what color shirt would you like? And you'd say yellow. And then they say, okay, any price? Or no, then you say, no, something under $60. So these frameworks, to do that, you have to have a structured capability. You have to be able to use data in a structured way. You have to have an ontology. You have to have a knowledge framework like we've built. You can't do that through machine learning alone. So that's that. And that brings me to something that's, and I get asked this a lot, mostly, why aren't the big companies doing this themselves? And I can tell you, everyone's working on these problems to some extent. They've been working on it for many years. The problem is it's a very difficult thing to do. And I always say this, I say this to customers, and I say this when I speak to people. Twiggle doesn't do magic. There's no magic here. It's not kind of a magic black box that we've just built something extremely powerful. We've dedicated many thousands and thousands of hours building this. We continue to build it and continue to improve it. And what's interesting and fascinating about search is that process doesn't end. This isn't like a communication application which you build and then you're ready to go to market and you never need to improve it again. This is constant improving. And while some companies, and I think there are very few that can actually take $100 million and dedicate a research team to figuring out and spending 3-4 years to develop this, I think for most companies it would be a lot more sensible to focus on what their core is, and to actually either partner with or work with microservices or people who have actually built this. In the case of what we've built today, there are companies, large companies working on similar projects, but to actually go to build this thing is hard. I'd be very, I congratulate any company that is working on this. I think it's fantastic for us and it's fantastic for the industry because it really pushes things forward. But it's not easy, and there are no shortcuts with this thing. It's a very deep and difficult technology, and we dedicated the last 5 years to actually building this. So it's a very large feat, and we've got one of the best search teams in the world who have been working on this for a long time. So which proves that this is not a difficult task, and I think many companies know that. But I think I'm really happy, by the way, about the recent IPO for Elasticsearch. I think it's a fantastic company, and they've changed. I think they've changed the industry. I mean, 6 years ago, the industry was very different, because we didn't have players such as Elastic with the dominance that they have today.
No, absolutely. And also from our side, congrats to the team of Elastic, but also to you. And I think it's a great story and good product. And I share your thoughts on that. Yes, many companies currently try to build everything also on their own. But my feeling is even if you have unlimited access to development resources, there's still too much to build and not enough time left. And the question is actually, what is the core technology as a brand or retailer or manufacturer that you're focusing on, and what are applications, microservices, components, whatever that you use and consume, and where actually. So the question is always, where should you invest on your own to make a difference, and where should you select best of breed, and then the solution in total that you deliver must be outstanding for your customers. Right? So,
Dirk, I think you've described what I think is the biggest issue today. What you've just said is the most important thing, that I think that all large companies, not only retailers, all enterprises need to, they're all working on their AI strategy or how they're going to adapt to this data-centric and algorithm-centric world. And I think the core thing that all large businesses need to ask is, what are we going to keep inside? What are we going to build, and what are we going to buy? And that's the biggest issue. And I think I see many large corporations, scratching their heads around this. It's a very difficult problem. It's a difficult problem, but it has to be, even not making a decision is a decision. But you have to make a decision. Is the Gap going to build a search engine? I don't think that would be a particularly wise thing for the Gap to do. I think the Gap have amazing clothes, and I think it would be great for them to focus on that part of the business, and take a search engine from someone else. And that applies to every other business as well.
I'm curious to learn what you are telling retailers when they ask you about voice. So where do you see currently the state of voice commerce, and how will it develop over time? Because so on the one hand, given your background at Google, GM, and now Twiggle, and so this is, I think, a perfect field for you. And you already mentioned it a couple of times in this episode shortly, but now related to commerce. So what do you think is the state today? How is it developing? And maybe also how is Twiggle preparing for that?
Yeah, so it's a great question. I mean, first of all, it's going, I'd say as an industry, voice, there have been very ambitious predictions about where voice commerce is going to be in 2020, 2021, 2022. These are very aggressive ambitions, and I think that voice-based shopping isn't picking up as fast as people thought it would. At least, by the way, in the Western countries, for instance, in China and India, it's actually going a lot faster. But it's not picking up as fast. And I think part of that is because of the lack of, one reason for that is for the lack of technologies such as those that we have developed. And I mean that I'm here to discuss a topic, not just to promote Twiggle, but I genuinely think to be able to provide good search technology, good voice-based shopping capabilities, you have to provide an experience which is actually useful. Beyond the hype around a new technology or a new interface, that interface has to be useful. And for a voice-based search or voice-based shopping, you don't just need to be able to recognize the accent or the voice. You actually have to be able to understand what is being asked for. And more importantly, you have to be able to give a useful response to that. So if I ask for a red dress shirt and I'm showed dresses, that's not very useful. And it makes it more difficult and actually quite annoying if I have to say it 5 times before I'm recognized or before I get a good response, and then I just get fed up and I don't use it. And I think that part of the problem with voice-based or speech to text systems or voice systems for commerce today is that they need to be part of a broader plan of the actual useful experience itself. What will that look like? What will the optimal medium be? So we've seen various attempts at that by Amazon, who really led the way with the Echo devices. But then we've seen very recently, and Echo is not primarily used for shopping. Echo, Alexa, they're used for many other things like asking the time, telling the weather, quick fact checking, and primarily playing music, but less shopping, because that's a very, very difficult thing to figure out. Actually, Amazon have set up here in Tel Aviv Alexa for shopping, building something, well, I think in a way similar to what Twiggle has built. And they've also recognized this approach as well. And I think what we've seen with the Echo devices is that you can ask us, if you ask, I want to listen to a Radiohead song, you can play the song and that would be a great experience. But if I ask for, a product, let's say it can be a product such as a pair of shoes, a pair of running shoes, how are you going to give me, sorry, did you hear me there? I got cut off for a second. How are you going to give me back options for shoes? Are you going to walk me through all the 10 results that I have? Are you going to choose the correct one for me? Are you going to speak it to me, or are you going to show it to me? Obviously, there's the Echo Show, which actually shows you the results on a screen. But that too, it's a suboptimal experience. Today, you can search for many things through voice and get really bad results. And that turns the whole thing into a difficult and quite unuseful task. So I think there's plenty of things to do here with when it comes to voice, but primarily where Twiggle sits in all of that structure. And we are now partnering with very large companies who do actually have conversational and voice-based applications and interfaces. We, like we do with the normal search, we sit as an API which provides the natural language processing part and the understanding part, the natural language understanding part of the query. So if a large company you were to talk into their phone, they would understand, they would recognize your speech. That speech would be translated to text, and then Twiggle would be able to take that text, understand that it's related to some kind of shopping related inquiry or query, and then Twiggle would be responsible for retrieving the right results in the right way with the right response based on the specific company's own internal commercial considerations. So they basically use our system as an infrastructure on which to build their ultimate interface.
That sounds very interesting. So
I think many things, just like most. Yep.
We unfortunately we're nearing the end of our time, and
sure.
only have time for one more quick question. So technology, great. I think it's just fascinating, and I'm really glad you were able to make time to talk about it. I do have one more question though. You're a fairly small company. How have you managed to get such a large amount of buzz out there? Right, you were Gartner's Cool Vendor of the Year last year in the commerce space, and I regularly hear about Twiggle from who's who of VCs out there and others. How, as a relatively small organization, are you able to outcompete the IBMs and Adobes of the world in terms of the PR buzz and talking about doing something new?
I don't know, really, to be honest. I can tell you what I can tell. We've got a very good team, so we've really got, people in the company who have led search at Google, led search at Amazon, led search at Yahoo, led search at Endeca and LinkedIn. So we've got a very, very good team. And the reason, by the way, that all these people chose to join Twiggle is because they really saw not only the uniqueness of the approach, but they actually saw the proof in the pudding itself. So they saw the results and they saw what we've been building, and everyone wanted to join this journey. Another reason perhaps for, I think there's lots of interest in this area now. I've been spent most of the last 4 years on a plane, which has allowed me to have many conversations with many different people across the world, and I've been lucky enough to talk with people like you, which is fantastic conversations that really spread the importance of these kinds of innovations, and many people seem to be interested in it, and luckily enough many companies seem to be kind of interested in this too. I guess that's the quick answer, but yeah, I think that it wasn't, we didn't plan to get lots of PR coverage. We just wanted to make sure we get to market while also managing all companies' expectations about how this technology will evolve in the future. So we had for e-commerce to meet what people expect of its future, several things have to change. One of the central things is search. It has to be different. It has to It has to not be the legacy search we've been used to. We want to get rid of all these bad results. We want to move into more advanced conversational systems, and able to do that. We spent a lot of time over the last 4 or 5 years talking about these topics, which seems to really have resonated with many people.
Yeah, well, congratulations on your success, and we wish you the best for the future.
You.
We'll be in touch. So thanks again for the interview. And with that, we will wrap up this episode of Commerce Tomorrow. Take care, everyone. Thanks.
Fantastic. Thanks, guys. Thank you. Bye-bye.
Thank you.
Bye-bye.
All right. So we're all good. Dirk,
Thanks, Amir. That was good.
Thank you, guys. And let's pick, it would be great talking to you. I forgot about the podcast at some points, which is a very good thing. And we should definitely pick up on other topics as well. You guys have my email, so
let me know when you are in Berlin. So
yeah, sure, I will.
When I'm in Europe, I'm mostly in Munich, but so definitely we should have a chat and yeah.
And also shop.org.
Fantastic, guys.
Or Shop Talk, we could connect at as well. I think that'd be a great event.
So yeah, that later.
Oh, fine. Yeah, okay, fantastic. Yeah, so we'll be at Shop Talk. Great, super.
All right, well, thanks again. We'll get this posted.
Thanks, everybody.
I'll send you a review, and we'll go from there. Thanks.